Hello, students. How are you all doing? All good? All honky dory? Okay, let's get started with the question at disposal. What being given over here is there's a particle which is projected at an angle 80 degree and it fragments at the topmost position at the pinnacle of its trajectory. What we do require as prerequisite or a precursor are few values, trigonometrical values. For example, cos of the angle 80 degree will be required. It is approximated, as you know, to 0.0173. We will require sine of the angle 180 degree value, which is approximated to 0.984. We would also require sine of the angle 160 degree, which is to 0.342 approximated. First things first, what being asked is if the particle breaks in two at the topmost position. Initially the particle was a unit in totality and mass of the particle being 14. It breaks in two particles with respective masses 9 and 5. So what will happen to a mass which drops dead? That is what we need to calculate. We need to calculate what will happen to it vis-a-vis distance traveled by it in x direction. So as per the range formula, we have v naught square sine 2 alpha by 2g to be calculated. Though here we don't require range, we require half of the range. Why so? Because the particle drops dead when it was a unit. It fragments in two and one of the unit drops dead at the position which is pinnacle of the trajectory. As it is pinnacle of the trajectory, time taken to travel that distance will be half of the time of flight, and distance vis-a-vis x direction will be half of the range. So what we need to find is half of the range, which from here can easily be calculated. When you divide range by 2, let's do the needful. When we divide it by 2, so range is v naught square sine 2 alpha by 2g, which is 64 square sine 180 degree 160, I'm afraid, 160 divided by 2g. Okay, this is what we have. We need to divide it by 2 to get answer to the first segment. So answer to the first segment being range divided by 2, which is to get us, when we place the values, 71.47, the answer. So this will be answer for the first ask by the author. Then the author going to ask, what will be velocity or x component of velocity, to be precise, of the particle which continues its journey. One, as we know, drops dead there, and the other continues its journey. So if it is in continuum, what will be Vx or x component velocity for that particle? Here what we make good of is our conservation of linear momentum knowledge. So we'll take a leaf out of our conservation of linear momentum book and try to figure what will be x component of the particle which is carrying mass m. What we do is find initial linear momentum. So before it fragments, before it breaks in two, the initial linear momentum in totality, in entirety, is 14, which is mass of the unit, multiplied with x component of velocity. you all are aware of why I am asking for only the x component of velocity at the topmost position. We have only x to fathom, we don't have y component of velocity. So going ahead with this is the linear momentum before of explosion. Now after explosion, one of the particle is not to contain any direction motion, by the way, but we over here are interested only in x direction as we are conserving along x axis. So x direction momentum for the particle with mass 9 is 0. Why so? Because it's not having any component of velocity in x direction. Vis-a-vis the second particle with mass 5, we multiply mass of it with velocity component in x direction. Calculating Vx, we get from here Vx equal to 64 cos of the angle 80 degree divided by 5. This will get us 31 as the value, 31 meter per second. So the particle which is in continuum with journey is moving with 31 meter per second. After off, you may say breaking off the particle into pieces, fragmentation or explosion. Last asked by the author, this is answered the second part, by the way. Last asked by the author is position at what will be, let me draw the case for you, what will be distance which is marked S in the graph or depiction, what will be S for the particle which continues its journey. So the particle which continues its journey is moving at the topmost position with 31 meter per second, and it has got to its merit a time t which we know as per the formula will shape to 2h by g. 2h by g, time of flight for this particle will be 2h by g, where h is this height from here to here. This height is known to us. How we know this height? This is the maximum height of the particle which was projected with a speed 64 meter per second at an angle 80 degree. So this is the velocity was 64, angle was 80. What do we get to see then is the maximum height, and maximum height as per the formula can be calculated 64. Let me write the maximum height equation first. V naught square sine 2 alpha by 2g. Sine 2 alpha by 2g. This is the maximum height equation. We can calculate maximum height by placing the values, and that value can be used in this equation to get time of flight. Why do we require time of flight? In order to calculate S, we'll have to multiply 31 with time of flight. That is 2h by g under the root. Why so? Velocity component along x direction will remain same as there is no acceleration in that direction. Multiplied with the total time of flight will get me S, this being S. This for second particle. When we put in the values, h is v naught square sine square alpha by 2g. We know the value of alpha 80. We know the value of v naught, which is 64. G, if it's not so indicated, we go by the supposition of 10. If it's indicated, we take 9.8. Over here, I'm not taking liberties. I'm marking it as 9.8. As we mark it as 9.8 and place in the values, we get to see S will tantamount to 200.11. You can place in the values out here. 31 to 8g, g 9.8. We get the value as 200.11 meter. Please do contact unflinchingly as per what the institute approves of. completely as deemed fit by the institute. If you do have any doubt left with you, thank you, all the best, see you again.